So today we'll start with software requirements engineering. So the first topic of software requirement engineering is understanding the requirements. Now, we have some of the idea about this requirements and requirements understanding. Okay, so starting with the problems with requirements practices. So what are the problems with the requirements, which is the crucial step in any software development lifecycle, right? So this the first is that we have trouble understanding the requirements that we do acquire from the customer. Then another problem is that we often record requirements in a disorganized manner. Okay, then we possible that we spend far too little time for verifying what we do record. Okay, and what are the main important concept of our related to our software development process? What are the main thing? Then we allow change to control the whole software process rather than establishing the mechanisms to control the change. And most importantly, we fail to establish a solid foundation for the system or software that the user wants to build. Okay, so apart from that, many software developers argue that producing a working program is the important, and apart from that, all is the secondary thing. Why? Because many software developers argue that building a software is so compelling that we should jump right into the developing the software. Okay, rather than having a clear understanding of what is required, what is important for the procedure. Things, and due to that, things will become unclear. Okay, if we do the thorough process, then the things will become clear for building the software, for building any software. Project stakeholders will be able to better understand what they need only only after going through thorough process, after examining the whatever the early scenario, early process of the requirement strategy, right? So things may change rapidly from the customer side, and we have to make changes accordingly. So the thing is that sometimes it is the scenario that the developers think that we have to directly start with the procedure, okay, by developing, because all these things is the secondary thing. So uh, it may possible sometimes that all of these arguments have some kind of truth, but a very little percentage of truth, especially for small projects that take less than 1 month to complete. However, as your actual large project software grows in size and complexity, these arguments begin to break down and can lead to a failed software project if we don't follow some particular strategy with respect to requirement strategy. Okay, with respect to requirement procedure in terms of gathering the requirements, understanding them first of all in a most possible way. So we may found some of the problems with this requirements. Now the solution is nothing but the requirement engineering. Now what is first of all the requirement engineering? As we know that a requirement is nothing but one kind of feature of the system, or you can say characteristics or the functionality of the system, or a description of something the system is capable of doing in order to fulfill the customer's need, the customer's criteria, okay, the system's purpose. So For that, we have to follow some strategy, right? So what is that requirement engineering? It is nothing but understanding the requirements of customer, and we have to document it, document all those requirements. That is nothing but a concept known as the requirements engineering. So it begins during the communication activity, and it continues into the modeling activity. It basically builds a bridge from the system requirements into software design and construction. Apart from that, it allows the requirement engineers to examine the context of the software work which is to be performed. It also focuses on the specific needs that design and construction are going to address. Apart from that, the priorities that guide the order in which your work is going to be completed. So all those things comes under this requirement engineering, the information, function, behavior that will have some specific impact on the resultant design, right? Now, there are some specific tasks of requirement engineering. Now, they are inception, elicitation, elaboration, negotiation, specification, validation, and requirement management. Some of these tasks may occur in parallel and all are adapted to the needs of the project. As per the given project criteria, these tasks are performed. And basically, the intention of this, all of this task is nothing but the customer's needs, to satisfy the customer need, their what the customer wants, their criteria, and also to establish a solid foundation for the design and construction of the software. Now we'll understand each of them one by one, starting with the inception. So during inception, the requirements engineer asks a set of questions to establish a basic understanding of their problem, the people who want a solution, the nature of the solution that is desired, and the effectiveness of preliminary communication and collaboration between the customer and the developer. Through this type of questions, the requirement engineer needs to identify the stakeholders. It is able to recognize multiple viewpoints, and they basically decide to work towards the collaboration by breaking the ice and initiate the communication. Okay, so these are just the overview of the questions. These are the set of questions that will be held in that will be asked by the requirement engineer to the customer, or you can say there are three sets. This is the first set of questions, the next set of questions, and final set of questions. Okay, so these are nothing but the questions which helped in this elicitation task. You can go through once. So these are the questions that we require in inception task. Now coming to the elicitation task, this eliciting requirements is difficult. Why? Because of the problems. Some of the problems are a problem of scope in identifying the boundaries of the system or specifying the technical detail rather than overall system objectives. Then the eliciting requirement is difficult due to the problem of understanding what is wanted from the customer side, what the actual problem domain is, and what the computing environment in which your software can be built. Okay, so another one is the problem of volatility. That is nothing but the requirements can change over time from the customer side. So this elicitation elicitation of requirements may be accomplished through two activities. The first one is the collaborative requirement gathering, and another one is the quality function deployment. Now, the collaborative requirement gathering is nothing but in that meetings are conducted and attended by both software engineers, like apart from software engineers, there are customers and other interested stakeholders, and some kind of rules for preparation participations are established in that meetings. One kind of agenda is suggested, which is, you can say, a formal way to cover all the important points, okay, or some of the ideas which are required for software development. So the customer, developer, outsider, like stakeholders, engineers controls this meeting, and a definition mechanism is used, such as like worksheets, flip charts, wall stickers, or you can say bulletin board, chat room. So these are the techniques that can be used for this elicitation of requirements. Now the goal is to identify the problem, propose elements of the solution, negotiate different approaches, and specify a preliminary set of solution requirements in this collaborative requirements gathering. Basically, this collaborative requirement gathering and quality function deployment is nothing but the two activities by which we can accomplish the elicitation task. Apart from that, in quality function deployment, which is a technique that translates the need of the customer into technical requirements for software. It basically focuses an understanding of what is valuable for the customer, and then deploys those values throughout the engineering process through some kind of functions, or you say information tasks, etc. Right. Now, it identifies these three types of requirements, as you can see: normal requirements, expected requirements, and exciting requirements. Now, what is that normal requirement? So, normal requirements are the objectives and goals stated for a product, or you can say for a system, during the meetings with the customer. Basically, these normal requirements reflect this whatever the customer is stating, whatever the customer goals and objectives which the customer states, that comes under the normal requirements. Okay, then comes the expected requirements. Now, what is that expected requirements? These are the implicit to the product or a system, or you can say those requirements may be so fundamental that the customer does not explicitly state them. Okay, and if those expected requirements, which are so implicit to the product and the customer did not state them, and if those requirements are missed from the developer's side, so you can say, we can say that the absence of those can cause the significant customer dissatisfaction, and that we don't want. Okay, after that, the exciting requirements. Exciting requirements are the, you can say, the some kind of features that go beyond the customer's expectation and prove to be very satisfying when they are present, when they are presented to the customer. So they go beyond the customer's expectation and concentrate on maximizing the customer satisfaction, whereas those expected requirements, it may possible that they are so implicit to the product or system, and it is so fundamental that customer does not explicitly state them. They want कि ये तो होना ही चाहिए, so that they don't explicitly state them, and they want from the developer's side that this should be there in your software. Okay, so those are the normal, expected, and exciting requirements. Now, during the elaboration task, the software engineer takes the information which is obtained during the inception and elicitation and begins to expand and refine them. Okay, the elaboration task focuses on developing a refined technical model of software functions, features, constraints, right? So you can say that it is an analysis modeling task which uses the use cases in which the use cases are developed, domain classes are identified along with some attributes, relationship that we know, right? The state machine diagrams are used to capture the life of an object in your software. So whatever the end result is there for this task is nothing but an analysis model that defines the functional, informational, and behavioral domains of the problem. Okay, so basically, the you can say the elements of this analysis model can be divided into these four elements: scenario-based elements, class-based elements, behavioral elements, and flow-oriented elements. Now, in scenario-based elements, as we know that it describes the system from the user's point of view, right? Using some scenarios that are depicted, you can say using use cases or using activity diagrams. Then comes the class-based element, so in which we know that we identify the domain classes for the objects which are manipulated by the actors, the attributes of the classes, how they interact with each other, they how they utilize those classes. Okay, so all those things are depicted using the class diagram. Then comes the behavioral elements. So they use the state diagrams to represent the system, to represent basically the state of the system, the events that cause the system to change its state, and the actions that are taken as a result of a particular event. So those all those things are nothing but the behavioral element. Then comes the flow-oriented elements. So as the name suggests, it uses a data flow diagram to show the input data that comes into a system, what functions are applied to that data to do transformation, and what type of resulting output that are produced as a result of those functions. Right. So these are the elements of the elaboration task in analysis model. Right. Then comes the negotiation task. So as the name suggests, during this task, the software engineer reconciles the conflicts between the customer wants, what the customer wants, and what can be achieved given limited business resources. Right, there is some negotiation between the customer for between the customer and the software engineer about what the customer wants and what can be actually achievable. So requirements are, you can say, ranked or prioritized by the customers, by the users, and the stakeholders together. And risks are associated, whatever the risks are associated with each requirement are identified, analyzed, and some rough guesses of development effort are made and used to assess the impact of each and every requirement on project cost and delivery time, because all those things should be decided. So using an iterative approach, requirements, whatever the requirements which are unnecessary, they are eliminated, combined, or modified so that according to need of the customer as well as what can be actually achievable in a given resources by using given business resources, so that each party achieves some measure of satisfaction. The customer should be satisfied, that is our main priority, as well as the software engineers should be satisfied in terms that whatever they are given, whatever the requirements they are given from the customer side, they know that this will be able to be developed. Okay, so there are some art of negotiation that we have to remember that it is not a competition. The both the parties, the customer as well as the software engineer, should recognize that it is not a combination. We should map out some strategy, listen actively, focus on the other party's interest, don't let it get personal, be creative, and be ready to commit. So these are some of the art form of negotiation. Then the next task of requirement engineering is specification. A specification is the final product final work product produced by the requirements engineer. It is the foundation for subsequent software engineering activities, and it can be any of the following: a written document, a set of models, formal mathematical collection of user scenarios, prototype. Okay, basically it is the foundation for subsequent software engineering activities. It is, you can say, the final work product which is produced by the requirement engineer. It serves as the foundation for subsequent software engineering. Right? It describes the function and performance of a computer-based system and the constraint, whatever that will govern the whole development process. It is in the form of nothing but the software requirement specification. It formalizes the informational, functional, behavioral requirement of the proposed software in both, you can say, graphical and textual format, so that everyone could understand that. Then comes the validation task. So during the validation task, the work products produced as a result of requirements engineering are assessed for quality. As the name suggests, this validation task is nothing for testing the quality. So the specification is examined to ensure that all your software requirements have been stated unambiguously. Uh, there is no inconsistency or error in content or interpretation, or nothing, no errors have been detected and corrected, right? The We have to identify the areas where clarification may be required, then conflicting or unrealistic requirements that is needs to be identified. The work products should conform to the standards which have been established for the process, project, or product. Okay, we have to work according to that only. So there are also some certain type of questions to be asked when validating these requirements, like is the requirement really necessary, or does it represent an add-on feature that may not be essential for the objective of the system? Is each requirement unambiguous? Okay, do any requirements conflict with other requirements? If so, we can eliminate that. Is each requirement achievable in the technical environment? Is each requirement testable once implemented? Okay, then does the requirement model properly reflect the information, function, or behavior of the system to be used? So all those questions are nothing but based on these things, whatever we have discussed. So these are the things by which we can validate the requirement. Okay, or you can say whatever the work product which has produced from that earlier stage, we have to qualify that, we have to assess for its quality. Now the last step is nothing but the requirement management task. So here, during the requirement management, the project team basically performs a set of activities to identify, control, and track the requirements, and also track the changes, whatever the changes are there to the requirements at any particular time as your project is going to proceed. So it basically means that it is going to involve the managing the change in requirements in this requirement management task. So these are nothing but the 7 requirement engineering tasks: inception, elicitation, elaboration, negotiation, specification, validation, and requirement management. Now we'll see the next topic. Did you get this? So the another important step in software engineering and software development is the design of the software. So Say, for example, that if we are going to build a house, okay, without a blueprint, then it is not a possible to that if we attempt to build any house without a blueprint, right? You in that case you would have some risk, errors, erroneous floor plan, that won't work basically, right? Some you don't have any plan that how you are going to build a house, where you would put windows or doors, or where you would put your drawing room, etc. So without a floor plan, without a blueprint, it's a kind of a mess, right? Same way, the computer software also needs some design, on the basis of which their software developers can build the project, right? So the Mitch Kapoor presented design manifesto, just like we have agile manifesto, if you remember, all the guiding principles for different phrases. So he also suggested some design manifesto in a Dr. Dobbs journal. He said, what do you mean by a good design, basically? Okay, a good software design should exhibit firmness, commodity, and delight. So, what is the firmness? So, a firmness means a program should not have any bugs that for related to its performance, its functionality. Commodity means that it should be suitable for the purpose for which it was intended. And the delight means the experience of using that program should be pleasurable one, which things should be satisfied. The software design encompasses a set of principles, concepts, practices that lead to the development of a high quality system or product. Then, the design concepts must be understood before the mechanics of design practices are applied. And third important point with respect to software design is that software design practices change continuously as new methods arrive. Okay, so a better analysis should be there and broader understanding should be there to deal with those changes. Now here is your analysis model uh, and the design model. So basically the mapping is shown here that the analysis model is mapped with which phases of your design model. Design model is basically contained with component level design, interface design, architectural design, and data or class design. And this is your analysis model, which we just saw right now in previous presentation slides, that scenario-based elements, class-based elements, behavioral elements, and flow-oriented elements. So all those things are mapped with this design model, which is saying that, for example, scenario-based elements are mapped with the interface design. Then flow-oriented elements are basically mapped with many levels of design, that is component level design with interface design with architectural design. Same way class based elements also are mapped with component level design, class design, architectural level design. Okay, so this is nothing but one kind of mapping of analysis and design model. Now, when we talk about the design, the quality is the important. Actually, the quality is the important factor in overall software development life cycle. The quality is important. The aim is nothing but the good quality of software. So, how can we achieve that? So, the first thing is the design must implement all of the explicit requirements. Okay, the design must implement all of the explicit requirements which is contained in the analysis model, and it must accommodate all of the implicit requirements desired by the customer. The next is the design must be readable, understandable guide. Okay, for those who generate the code, because on the basis of that only we are going to, on the basis of those blueprint only we are going to build the house. Same way, on the basis of those design only, the developers who are going to generate the code. For those who taste it, that for them also the design should be in a form such that it should be readable and understandable kind of guide. Okay, the third one is the design should provide a complete picture of the software, addressing the data, functional, behavioral domains from an implementation perspective. So that is nothing but the design, right? So by having all those things, we can focus on the quality of the design. We should maintain the quality in such way that it can helpful for the upcoming activities in a software life cycle. Apart from that, software design should exhibit an architecture that has been created using recognizable architecture styles or patterns. It should be composed of components that exhibit good characteristics, good design characteristics. It can be implemented in an evolutionary fashion, right? Apart from that, a design should be modular. That is, the software should be logically partitioned into elements or subsystems. Then, the design should contain the distinct representation of data, architecture, interfaces, etc. A design should lead to data structures that are appropriate for the classes to which are to be implemented and are drawn for the data patterns. Data design should lead to interfaces that reduce the complexity. It should be derived using a repeatable method, that is nothing but it should be driven by information obtained during the software requirement analysis, and a design, whatever the design, software design should be represented using a notation that so that we can effectively communicate whatever the meaning we want to convey, right? Now, there are some fundamental concepts related to design. The first one is the abstraction. So, what is the abstraction? As we know, we have studied some of those concepts of this abstraction, like you have studied in WT subject. Okay, the starting with the abstraction, it is nothing but the of uh, process, or you can say result of generalization by reducing the information, content, or a concept, or you can say basically we are reducing the information typically in order to retain only the information which is relevant for a particular purpose. Okay, then comes the software architecture, which refers to all the overall structure of of the software, and the ways in which that particular structure provides the conceptual integrity for your system. So the architecture should be good, because the good software architecture will give you in return good cost. Okay, and ultimately it would lead you to the better customer satisfaction if you have satisfied the cost criteria or the investment criteria, and whatever you get after that particular architecture, if you get a desired outcome for your project, then it would all be successful. Then comes the patterns. So it is nothing but it describes a design structure that, and that structure particularly involves uh, a solution, kind of solution for a design problem. Okay. It basically describes a design structure, and that structure solves a particular design problem in a specified content in a specified way. Then comes the separation of concern. So any complex problem can be more easily handled if it is subdivided into pieces. That is nothing but the separation of concerns. Then comes the modularity. So software architecture is divided into components called modules, right? So single module or the single attribute of software that that should be managed in some way. It should be managed in a way that can be individually, that can be independently exist. Then comes the information hiding. So modules should be specified and designed so that information contained within a single module is inaccessible to other modules. Then comes the function independence. So the functional independence is nothing but the concept of separation, and it is also related to the concept of modularity, uh, abstraction and information hiding. Basically, this functional independence in terms of software design is accessed using two criteria, that is the cohesion and coupling. What is the cohesion is nothing but the indication. Have you do you know about cohesion and coupling? Any idea? Yes, anyone? What is cohesion and coupling? See, cohesion means cohesion means the degree of interdependability within elements of a module, and coupling means the level of interdependability among the modules. Right. So coupling is nothing but how your module is going to interact with the another module, and cohesion is nothing but how your module, how your particular module and whatever the components of that modules are interact within themselves. That is nothing but the cohesion. So the cohesion should be high and coupling should be low. Okay, that is your good design architecture. High cohesion and low coupling. The interaction between the amongst the modules should be low, but the cohesion, that is the degree of interdependability within the elements, within the components of a module, that can be high. Then comes the refinement. So it is a process of elaboration of details of abstraction, and the stepwise refinement is a top-down design strategy. Okay, so abstraction is nothing but we are only showing the relevant information, whereas this refinement is the process of elaboration of details of abstraction. So these abstraction and refinement are, you can say, the complementary concepts. Then comes the aspects. So a mechanism, again, a mechanism for understanding how global requirements affect design. How? So say for example, there are two requirements, requirement A and requirement B. Now, it may possible to satisfy that some requirement B is only satisfiable if we taken into if we take requirement A into account. Okay, if we consider requirement A in terms to satisfy that requirement B. So this aspect is how your global requirements affect your design, how those each requirements affect each other. Then comes the refactoring. So it is a reorganization technique which simplifies the design of components without changing its function behavior, right? It is technique that is focusing on the design of components without changing its function behavior. Then comes the object-oriented design concepts. So again, there are the concepts like inheritance, messages, polymorphism, right? So basically, all those things focuses on the objects, which are nothing but the abstraction of the real world or the real system, and they are basically representing the real system entities and how they are going to interact with each other. Okay, and objects are independent and encapsulate the state and represent the information, and all those concepts, inheritance, polymorphism, are there. And then comes the design classes. So the model of software is designed as a set of design classes. Like every class describes the elements of problem domain and that focus on features of the problem which are user visible and all those things. So design classes are nothing but the there should be some particular characteristics of design classes, like it should be complete, it should be sufficient, the primitiveness should be satisfied. Then as I told you that the high cohesion and low coupling should be there. Okay, so all those things are the characteristics of design classes. It is again the requirement model that defines this set of design classes, and they provide uh, basically they provide you the analysis classes by providing whatever the detail, whatever the design detail is there, that will ultimately enable the classes to be implemented, and ultimately they help you to implement a software infrastructure that would support the business solution. Okay, so whatever the design classes are there, each of those design classes describes the elements of problem domains that focus on features of the problem, which are visible to the customer and which are ultimately the needs or wants from the customer sides. And those characteristics of the completeness, sufficiency, primitiveness, okay, high cohesion, low coupling, that should be satisfied in terms of design classes. Now we'll see the types of cohesion and coupling in the next lecture.